Hello everyone, welcome back to the channel. In today's video, we will continue to learn about the sensors in modern cars. I will help you understand each sensor's location, function, signs of failure, and how to test them. Please listen carefully because understanding these sensors will help us diagnose and repair vehicles more easily and accurately. Let's begin. First of all, a car is a complex machine. It operates through the perfect combination of the engine, the transmission system, electronic control systems, and safety systems. The internal combustion engine generates power. The transmission system delivers that power to the wheels, and the electronic control system constantly monitors and adjusts every activity so that the car runs smoothly, powerfully, and economically. Second, why are sensors so important in a car? For the electronic control system to work accurately, the car is equipped with many sensors. These sensors detect information from the environment and from the engine itself. Then, they send all that data to the main control unit, known as the ECU. The ECU processes this data and makes control decisions, such as fuel injection, ignition timing, throttle adjustments, and operation of safety systems. If a sensor fails, the car will run unevenly, fuel consumption will increase, and safety could be at risk. Now, let's carefully analyze each type of sensor in detail. Let me know if you'd like me to help write out the next sections for each sensor. Morn. Crankshaft position sensor. Location. It is usually located near the flywheel or next to the crankshaft pulley. Structure. This sensor is typically a Hall effect type or a magnetic sensor. Function. Its job is to send signals about the crankshaft's position and rotational speed to the ECU. Working principle. As the tooth wheel spins past the sensor, changes in the magnetic field create electrical pulses. Importance. This sensor is extremely important because it helps the ECU determine the exact timing for fuel injection and ignition. Common fault symptoms. When this sensor fails, the engine may have trouble starting, may misfire, or may stall unexpectedly. How to test. You can measure its resistance with a multimeter, check the signal output, or use a scan tool for diagnosis. Cam 2, camshaft position sensor. It is mounted at the end of the camshaft. Structure. This sensor is also either a Hall effect sensor or a magnetic type sensor. Function. It detects the exact position of the camshaft, allowing the ECU to control fuel injection with high precision. Working principle. It works by detecting changes in the magnetic field as the camshaft gear spins. Common fault symptoms. If this sensor is faulty, the engine may be hard to start, lose power, and fuel consumption will increase. How to test. Use a multimeter or an oscilloscope to check the output signals. 2-3. Knock sensor. Location. Usually found on the engine block. Structure. Inside the sensor, there is a piezoelectric crystal. Function. It detects abnormal vibrations caused by engine knocking. Working principle. Mechanical vibrations are converted into voltage signals which are sent to the ECU. Importance. This sensor allows the ECU to adjust ignition timing, helping to prevent engine damage from knocking. Common fault symptoms. If it fails, you may notice strong engine vibrations, poor fuel economy, and unstable engine performance. How to test. Check the sensor's resistance with a multimeter and verify the output signal with diagnostic equipment. 4. Throttle position sensor. The throttle position sensor is located on the throttle body. Its structure is a potentiometer, which is a type of variable resistor. The function of this sensor is to measure the angle of the throttle valve opening. The working principle, the output voltage changes according to the throttle position. When this sensor is faulty, the engine may hesitate or have poor acceleration. To test it, slowly move the throttle and check if the voltage changes smoothly. Oxygen sensor. The oxygen sensor is installed on the exhaust manifold. It is built using a zirconia electrochemical sensor. Its function is to measure the remaining oxygen in the exhaust gases. The principle is simple. It generates different voltages based on the oxygen content. If the sensor fails, you may notice increased fuel consumption and the check engine light will turn on. For testing, connect a diagnostic tool and check the sensor's signal readings. Engine coolant temperature sensor. This sensor is mounted on the engine's coolant line. It uses a thermistor, which changes resistance with temperature. The function of the sensor is to measure the temperature of the coolant. The principle, As the coolant temperature changes, the sensor's resistance changes accordingly. If it is faulty, the cooling fan might not work properly, and the engine can overheat. To test it, measure the resistance of the sensor at different temperatures. 7. Mass airflow sensor. The mass airflow sensor is located on the air intake duct. Its structure is a hot wire sensor. The function of this sensor is to measure the amount of air entering the engine. The principle: as air flows over the hot wire, it cools the wire, and the ECU uses this change to calculate air intake. Common symptoms of a faulty MAF sensor are reduced engine power and poor fuel economy. For testing, check the signal voltage from the sensor while the engine is running. At manifold absolute pressure sensor, or MAP sensor. Location: mounted near the intake manifold. Structure: uses a piezoelectric element. Function: measures the pressure inside the intake manifold. Working principle: when pressure changes, the diaphragm inside the sensor bends and generates an electrical signal. Common symptoms of failure: the engine becomes weak and fuel consumption increases. How to test: compare the sensor's output signals with the manufacturer's standard values. 9. Intake air temperature sensor, or IAT sensor. Location: installed inside the air intake duct. Structure: made from a thermistor, which is a temperature-sensitive resistor. Function: measures the temperature of the incoming air before it reaches the engine. Working principle: the sensor's resistance changes according to the air temperature. Common symptoms of failure: the vehicle loses power and the air-fuel mixture becomes incorrect, leading to higher fuel consumption. How to test: measure the resistance and check the output signal against standard specifications. 10. Accelerator pedal position sensor. Location: mounted on the accelerator pedal assembly. Structure: a type of potentiometer, also known as a variable resistor. Function: sends signals to the ECU that indicate how far the pedal is pressed. Working principle: as the pedal moves, the voltage output changes. Common symptoms of failure: the acceleration becomes unresponsive. Pressing the pedal feels sluggish or has no clear reaction. How to test: check the signal changes by pressing and releasing the pedal while monitoring voltage output. Study 11. Wheel speed sensor. Location: installed at each wheel. Structure: a magnetic type sensor. Function: measures the rotation speed of each individual wheel. Common symptoms of failure: the ABS warning light turns on in the dashboard. How to test: check the pulse signals coming from the sensor using a multimeter or oscilloscope. Tire pressure sensor. Location: positioned inside the tire valve. Structure: contains a pressure sensor module. Function: monitors the tire pressure and alerts when the pressure is too low or too high. Common fault symptoms: the system may give incorrect pressure warnings or display alerts even when the tire pressure is normal. Testing method: connect a diagnostic scanner to read live data from the sensor and compare it with actual tire pressure. Start 13. Transmission sensor. Location: installed on the transmission housing. Function: measures the output shaft speed and detects the gear position. Common fault symptoms: the vehicle may experience harsh shifting or shifting at the wrong times. Testing method: check the sensor's output signals using a diagnostic tool or an oscilloscope. TAS 14. Brake pad wear sensor. Location: mounted on the brake assembly. Function: alerts the driver when the brake pads are worn beyond the safe limit. Common fault symptoms: no warning light on the dashboard even though the brake pads are already worn out. Testing method: perform a visual inspection of the brake pads and check the sensor signal for continuity. 15. Acceleration sensor. Location: attached to the vehicle chassis. Function: detects acceleration forces in multiple directions to support stability systems. Common fault symptoms: ESP or ABS warning lights appear on the dashboard. Testing method: use a diagnostic scanner to read fault codes and view live signal values from the sensor. Distance sensor. Location: installed on the front and rear bumpers. Function: measures the distance between the car and nearby obstacles. Fault symptoms: false proximity warnings or alerts without any objects around. Testing specialized diagnostic equipment to check signals and detect faults. Light sensor for automatic headlights. Location: positioned on the dashboard. Function: detects the level of ambient light and controls the automatic switching of the headlights. Fault symptoms. Headlights do not turn on or off automatically when it becomes dark or bright. Testing. Observe the sensor's response when changing the surrounding light conditions. 18. Front airbag collision sensor. Location in the front engine bay. Function. Detects impact and triggers airbag deployment in case of a collision. Fault symptoms. The airbag warning light stays on in the instrument cluster. Testing. Use a diagnostic tool to read fault codes and check the sensor condition. 19. Interior and exterior temperature sensors. Location. The interior sensor is placed inside the cabin, and the exterior sensor is located near the front grille. Function. Measures the temperature inside and outside the car to help the climate control system work accurately. Fault symptoms. Poor climate control performance, such as incorrect cooling or heating. Testing. Check the sensor output signals using diagnostic equipment. As you can see, each sensor on the car has an important role in ensuring safety, comfort, and fuel efficiency. Knowing where each sensor is located, how it works, and how it fails will make our repair work much more effective. I hope this video has been helpful for you. Thank you for spending your time with me. If you find this content useful, please like the video and subscribe to the channel for more. See you in the next video.